Hi, welcome to the video solution for physics past paper. This is Edexcel IAL Physics, Unit 2 of October 2017, Part 2. Let's start. Question number 12. The speed v of water waves in shallow water is dependent on the depth d of the water as given by. So v is equal to square root of gd. Explain how transverse wave moves across the water. So motion of the transverse waves are that the oscillation are perpendicular to the direction of propagation. So particle oscillate up and down, for example, and wave is moving horizontally. So both are perpendicular. That's why we call it transverse wave. Water molecule oscillates perpendicular to the direction of propagation of the wave. A student investigates the speed of water waves using a tray of water. He quickly raises and lowers one end of the tray. A wave moves across the water and is reflected when it reaches the other end of the tray. The student measures the time taken for the wave to travel 4 length of the tray. He also measures the length of the tray and depth of the water in the tray. He repeats this for different depths of water. Describe how the student can use his results to verify this equation by graphical method. So if you see, you need to plot the graph using this equation, and we are looking at value of g here, which is 9.81. So if a student can manage to plot the graph from which he verified the value of g, that means this equation is verified. And for this equation, depth he is measuring from the tray. What about the velocity? So what a student should do, he must use v is equal to s upon t, distance upon time. This is the basic formula for speed. So speed is equal to displacement upon time, but in this case this displacement should be 4 times of the length of the tray. Why? Because his waves travel 4 length of the tray. That's why the distance should be 4L and divided by time measures, so he can have a velocity of the wave, and he can take different measurement for different depths, so he would have multiple value of v and d. And then according to this equation, if you rearrange this equation, v square is equal to gd. Clearly v square is directly proportional to d with gradient of v square over d. This is the gradient. That means a student should plot graph of v square on the y-axis and d on the x-axis, and he can expect a straight line passing through a region, and from a straight line he is going to measure the gradient, and gradient should be equal to g, 9.81. A teacher demonstrates the Doppler effect using a rotating source of sound. He swings a buzzer on the end of a string in a white circle. The buzzer emits sound with a constant frequency. A microphone connected to a computer is placed in front of a teacher to measure the observed frequency of the sound wave. A graph of observed frequency f against time is obtained. This is a graph. State the frequency of sound emitted from the source. So sound emitted from the source is the original frequency without any change or without any effect of Doppler motion or Doppler effect. That means this 400 is the frequency of the sound without any change. So for AI, frequency of the sound is 400 Hertz. A student conclude at time tx the buzzer is moving away from the microphone. Justify the student's conclusion. So students saying that at tx buzzer is moving away, and this is tx, and if you see at this time, this is the frequency. Clearly this frequency is less than 400. So you can say that at tx frequency is less than 400, and which shows that the buzzer is moving away. So students' statement is correct. The speed of the rotation of the buzzer is increased. On the same axis, sketch the graph of f against t that would now be obtained. So speed of the rotation is increased. That means there will be a larger change in frequency in a shorter interval of time. So you can plot something like this, but it should be a larger, something like this. A longitudinal wave consists of series of compression and rarefaction. The diagram represents the position of particles at equilibrium and the position of particles at time t. This is equilibrium, this is disturbed particle. Label with a C on the diagram a position where a compression occurs at time t. So this is time t and these two are compression, so you can label this as C or maybe this is C. AII, take a measurement from the diagram to determine the wavelength of the wave. Taking measurement from the diagram, meaning you need to find the wavelength, and wavelength is distance between two consecutive crust or trough, or distance between two consecutive compression and rarefaction. So you can take your ruler, and this is the one compression, another compression, so you just measure the distance between these two compression. So this should be equal to the wavelength, and if you do that, because this is not exact diagram on my computer laptop screen, if you do this in your past paper, so you should get this length as around 5.4 centimeter. This is the wavelength. So you use your just a ruler to measure the length. A longitudinal waves can also be represented as a sine graph of the displacement and particles against distance along the wave. On the axis below, draw a displacement distance graph that corresponds to the longitudinal wave. So because I know that the compressions are clearly shown here and this is the one wave, so I can just draw a one transverse wave between these two compression to show the one wave. So I can start, so because I need to draw one wave means either this or maybe this. So I need to figure out this center point. So how many interval do I have? So 1, 2, 3, 4, 5, 6, 7, 8. 8. That means this is 1, 2, 3, 4. This is the middle point where we can have a zero displacement for our transverse wave. So I can start from here. Something. And if you wish, you can continue to moving like this and so on. (15) In a demonstration of photoelectric effect, electromagnetic radiation is incident on a clean metal surface. Electromagnetic radiation of frequency 1.8 10 to the power 15 Hertz is incident on a metal surface of a work function 3.7 electron volt. Explain why photoelectrons will be released. Your answer should include calculation. It's not that difficult. because we know the frequency of incident photon and the required energy to emit electrons. So we can figure out energy associated with this photon, E is equal to HF, and then we can compare this energy with the minimum energy. If energy of incident photon is greater than this, then electron will emit. Otherwise, if this E is less than 3.7, electron will not emit. So how do we do that? First, we figure out energy. E is equal to HF, and H is 6.63 or 625, 10 to the power minus 34, into frequency is 1.8, 10 to the power 15. And when you solve this, you have energy in joule, 1.2, 10 to the power minus 18 joule. And this joule should be converted into electron volt. So if you convert this joule into electron volt, dividing by 1.6, 10 to the power minus 19, so you have energy E is equal to 7.46 electron volt. So clearly 7.46 is greater than 3.7. That's why electrons are emitted or released from the metal surface. The electromagnetic radiation transfers energy to the metal surface at the rate of 1.8 times to the power minus 9 joules second inverse or joules per second. Calculate the maximum number of photoelectrons that can be released in each second. Okay, so we have found the energy of one photon. So we can say that one photon has energy 1.2 10 to the power minus 18 joule. And how much joule do we have in 1 second? So 1.8 into 10 to the power minus 9 joule per second. And so we can figure out the number of photons corresponding to this amount of energy. And if you do cross multiplication, X is the number of photon, which is equal to 1.5 10 to the power 9. These are number of photons. The photoelectrons are released instantaneously. Explain how this provides evidence of the particle model of light and not the wave model. The reason is because you know that it is a one-one interaction between photon and electron, and photon is absorbed by electron instantaneously. Photon is absorbed. That's why electron comes out instantaneously. But according to wave model, it takes time to absorb the wave, so there must be some delay in the emission of electron, and that's why wave model cannot define or cannot explain the photoelectric effect. (16) A microwave oven are used to cook food. Microwaves are emitted inside the oven and reflected from sides, from forming standing waves. One problem with using microwave oven is the formation of hot and cold spots within the food. Explain how hot and cold spots are formed within the food. So because during formation of a standing wave, we have an interference of reflecting microwaves, and at some points we have a constructive interference, constructive interference that cause formation of antinode. That means we have hot spot there, and due to destructive interference we have node formation at that point, so we have cold spot. The distance between two adjacent hot spots in the food is 1.4 centimeter. Calculate the frequency of the microwave. So if you need to find the frequency of the microwave, so for frequency we have a formula: F lambda is equal to speed of microwave, which is c 3 into 10 to the power 8. That means to find frequency we need wavelength. And how do we figure out the wavelength? We are given distance between two adjacent maxima or two adjacent antinode or two adjacent hotspot. So you can visualize two hotspots or two adjacent maxima like this. So this is one maxima or antinode, another one, and distance between these two is 1.4 centimeter, and distance between two adjacent antinode is always in term of wavelength is lambda by 2. So meaning lambda by 2 is equal to 1.4 centimeter. That means wavelength is 2.8 centimeter, and then you can convert this centimeter into meter, dividing by 100, so 0.028 meter. And then frequency is c by lambda. C is 3 into 10 to the power 8 speed of light or speed of microwave. Lambda is 0.028, and then frequency is 1.07 10 to the power 10 hertz, or you can round it off till 1.1. Suggest how the effect of hot and cold spots is reduced by placing food on a rotating turntable. So rotating turntable make sure that the position of nodes and antinodes keep changing constantly, so the whole region of the food can pass through the maximum hot spot, so it's being heated uniformly. B. The interference of microwave can be investigated in the laboratory using microwave transmitter and receiver. Microwaves from the transmitter passes through two slits. These are two slits and transmitters, so two waves are coming out from this gap. That means diffraction is going on, and of course after diffraction we should have interference, and we could have maxima and minima. So as the receiver is moved along AB, alternate point of maximum and minimum readings are observed. Explain why O is point of maximum reading. So point O, this is the center of the screen. So if one wave is coming from slit 1, so if you see that, and the other wave is coming from there, like this, so they will travel same distance, so there will be no path difference. So path difference would be 0. So if path difference is 0, we always have a constructive interference or maxima. That's why at O we always have maxima, because of 0 path difference. Explain why maximum and minimum readings are observed alternately as the receiver is moved along the line AB. So if the receiver is moved along the line AB, so you can say that the ray 1 is coming from there and the ray 2 is coming there. So definitely there is a path difference after reaching on the screen. So if the path difference is n lambda at that point, then you have a maxima, and if the path difference is n plus half of lambda at that point, that refers to a minima or a destructive interference. Thank you very much for this video. Have a nice time.